Assalamualaikum and hi to Penawan, TS Dr. Muhammad Syarif, TS Dr. Muhammad Syarif bin Azhar, and to Pena 2, IR Dr. Muhammad Faris bin Haji Mat Basar, Haji Mat Basar. Today I'm going to present about the Bachelor Degree Project 2, development of the GSM based on smart meter. Before that, let me introduce myself. I am Muhammad Firdaus bin Muhammad Khairi, matric number B0818100071. My supervisor TS Dr. Muhammad Hatta bin Jopri. My course BEI. Our agenda style today is first introduction, project objective, problem statement, scope of project, literature review, methodology, simulation and hardware development, result and discussion. Lastly, conclusion. First, introduction. The technology of e-metering, electronic metering, has begun through the technology advancement, and there is increased demand of the reliability of the efficiency automatic meter reading system. This project represents to design to wireless GSM energy meter installation where interface for the automated billing. The purpose of the system to replace the traditional meter reading method and enable remotely access existing energy meter by the energy provider of all consumers. Also, they also can monitor the meter reading regular without person visit each house. A GSM based on wireless communication module is to integrate with the electronic energy meter of the each internet have the remotely access over the instead of electricity. Our project objective is first to develop GSM module to the implement of the monitoring and the control in the system. Second, to monitor, analyze and the consumption of energy consumption based on the Arduino. And lastly, to remotely disconnect power supply at the house. Problem statement. First, meter reading error caused by the meter or the human. There are a lot of error sometimes by metering or by human. Next, the star amount the revenue loss being incurred by the country due to energy diff, which is a serious problem. People try to manipulate their meter reading by the adopting of various corrupt practices such as current reversal, partial fault condition, bypass the meter, and magnetic interface or others. And then to overcome the careless usage of the electricity by the consumer who is unawareness about the cost. Scope of project: communication between GSM and smartphone and smart meter energy, measurement of the voltage supply, current, power factor and units, coding GSM using the Arduino IDE, operate with the 230 volt single phase and 50 Hz power source. List of the literature review I have made it. On the first literature review, this is it. First and second, this is about the implement of the completely automated electricity billing system may set up. The purpose of automatic measurement of the monitoring electricity consumption by the consumer in the certain area, communicate the consumer power to the station, and the issue of charge for the consumer power. For the next literature review, even the latest energy meter is not tamper proof, hence the condition all the factor is the possible to design energy meter that tamper proof and support automated metering and the billing system. At the same time, help to identify a fault location of the transmission line. And the last of the literature review, this paper describes to how implement of metering communication to the assess energy consumption in home, and the outage automatically create a billing that can help to reduce the outage of the home because the owner of constantly inform the amount of the unit consumer. Next, methodology. Here is the implement of the chart. It starts with the power supply 230 volt. We continue to the energy meter and the Arduino with energy meter and load, relay, and Arduino communicate with the GSM module, and GSM communicate with the smartphone. Okay, this is a flowchart. Start and flowchart about the methodology. First, start and design. Use the Proteus. Next, ICE simulate, and if found any error, it will continue to design the Proteus, and if yes, I will continue to do a hardware and development. After that, I do a lot of troubleshooting. If yes, I will continue to fire a testing and end. If no, I'll still do a troubleshooting. Simulation and hardware development. Okay, here the list of hardware I use. First is Arduino Uno. Arduino Uno is open source platform that may be used to design and programming electric circuit and device. It has ability to receive and to deliver the information to most of device, and it can even command a specific electronic equipment through the use the internet to the program the board, and we use the specific of version C++. The second equipment we use is energy meter. Of course, energy meter is device used to the measure amount of the electric energy. And the third equipment we use is the GSM. This is the main part of the project. GSM is the global system for the mobile communication. It for wireless communication standard for the mobile telephone system. It was developed by the Europe Telecommunication Standard Institute as the replacement the first gen analog cellular network. And for equipment, we use the SCS712 current sensor. The purpose of this SCS is fully integrate and have a base inline current sensor with 2.1 kilovolt RMS voltage installed, and integrate low resistance current conductor. Essentially, term of the simply put, the form and the current sensor used to conduct of the calculate and measure the amount of the current applied. Next, relay. Relay are the switching which is aimed to closing and opening the circuit. Electronic as well electromagnetic, it control the opening and the closing of the circuit contact of the electronic circuit. And the last is AC voltage sensor module ZMPT 101B. Is a voltage transformer used to measure AC voltage measurement voltage up to the 250 volt by using this module. Next, as we can see, this is my simulation circuit produce. It start from the supply with 230 volt and it connect to the voltage sensor ZMPT. To ZMPT, the output the input we connect to the A2 in Arduino, and the current sensor will connect to the A3 to the Arduino. The GSM will connect to TX and RX at Arduino in pin 1 and 2, 0 and 1. Next, as you can see here, this is my interface of my hardware. In front of this, I made with the smart metering with the laptop with the plug-in 13 ampere. To make it easy, I test any load on that. On this experiment and this project, I test 3 type of load. First, toaster, rice cooker, and lamp. Okay, as we can see here, this is inside of the box. First, we can see GSM, Arduino, current sensor, voltage sensor, and RTC. Okay, we continue to the calculation. Here we calculate based on 3 types. First, rate block category 1 until 200 kilovolt. It will divide by 0.218. And second, we calculate start from 201 kilowatt hour until 300 kilowatt hour. We minus by 0.334, and last 301 until 600 kilowatt hour. We divide by 0.516. As here we also can see the programming calculation. Continue to the result and discussion. Okay, Here this is the chart of the price based on 3 type of load. First lamp, second toaster, and the last rice cooker. Okay, all the price is start from 0 and will continue increase by step. As you can see here, the higher price is rice cooker and the lower price is lamp, while the toaster is in the middle between rice cooker and the lamp. Okay, here this is chart of voltage supply. I measured the voltage supply based from the 1 minute until 10 minutes based on 3 type the load. As we can see here, the voltage supply of the lamp is very high and the lower voltage supply is rice cooker and toaster. Since the load is very small, the voltage is very high. Next, this is the result about communicate interface between the GSM module and the smartphone. Below is example result interface between GSM module and smartphone. As we can see below, condition is load on is with the energy 1.97 and the current price is 0.02 cents. The next meter with the condition load cut off and the energy is 0.02 and the current price is 0.05 cent. To communicate between the GSM module and smartphone, we just type the capital S only and the GSM will send back the current data to the user. For conclusion, a smart meter which take advantage of the GSM solve the problem of the manual meter reading, but also provide the additional features such as the power disconnect, the outstanding, the power reconnecting after the pay, do a power cut alert, temporary alert, and changing the method. Even I've changing the method from the based on calculation to the current sensor and voltage sensor, is still function. To the feature where is better, GSM have been replaced with the IoT to get more stability and interface with the smartphone. We continue to the poster. Okay, here as we can see, this is my poster development of the GSM based smart meter reading. Introduction, objective, research and methodology, result and discussion, conclusion and the feature work, reference. Lastly, we continue to the hardware part. We continue to the hardware part. Okay, here is my hardware part, which is first is power supply. Smart meter. Smart meter is connect to the supply 230 volt, and then we plug in with the load. Here today is we use a load as a bar lamp bar, and then as we can see here in serial monitor, since I don't use LCD display, I just look out from the serial monitor. Here the load is on condition, which is we can see all the value here and the price. Here I set the price will cut off when they reach 2 cent. Okay, how the user will know their bills? First, they need to message with the GSM module with typing the capital S only. Here, as we can see, S, I will send. Okay. Here, we can see the GSM will reply on the load based on the current reading. Here, as we can see, is the negative 0.07 energy and the negative 0.01 cent, and the load still on. As you can see, the load is still on. Okay. Why the energy and the price is negative? First, I have some of error in the connection. I not found to fit it, so I will continue. I change the coding to the negative. It will cut. It when the reach a negative 2 cent, it will cut off. Okay, we wait until the negative 2 cent to cut off the bar. Here we can see the price is reach the 0.01 cents and the load still on. It will cut off when the load reach negative 0.02 cent. Okay, as we can see here, the price right now is reach negative 0.02 cents. Since we set the value cut off is 0.02 cent and the load will off.